Okay, this is the last part for chapter 1. So we are still in two-dimensional flow in soil, but now we are looking for the flow net of anisotropic, which is the permeability horizontal different with the permeability vertical. And also we will go a bit detail about the piping problem and the prevention method of piping problem, and also about the design of filter. So the learning outcome, okay, should understand the flow net on anisotropic soil mass, and then understand the instability due to piping problems and prevention method of piping problem, and also the design characteristic of filter. So we start with the flow net for anisotropic soil mass. So when we are talking about anisotropic, it refers to the soil mass that consists of numbers of layers of different soil, meaning that in a soil mass we have different properties of soil. So each soil will have the different permeability. So the horizontal and vertical permeability will be different. But then the heat loss, okay, between the entry, okay, between the entry and the exit, okay, entry, exit, will be the same for each layer. So the H1 will equal to H2 will equal to H3. Alright, the heat loss. So the hydraulic gradients will be the same. Okay, so to construct the flow net for the anisotropic, alright, so by scaling the x distance by square root of kz over kx. Okay, kz referring to the vertical permeability and kx referring to the horizontal permeability. And then at the end of the day, you will need to calculate the quantity of seepage by using these equations. It's quite similar with the isotropic, okay, previous cases. Alright, but for the K we will have this value. Alright, okay, so for example, so if we have the dam structures initially, alright, the length of the base is 100 meter with the height of 20 meter, and given the K vertical and K horizontal as shown here. Now in order to sketch the flow net, to draw the flow net, we need to redraw the structure. So to redraw the structure, we need to use these equations, okay, as shown previously. So we have to transform the x distance by using these equations. So we have the K for the vertical distance, so for the vertical permeability is 1.5 meter per day, and for the horizontal, for example, we have 3.46, and we will time with the 100 is the initial base of the dam, the length of the dam, 100. So when we calculated, we have the x transform is 65.84. so before we draw the flow net, so we should redraw the structure using the new base length calculated. So instead of use 100 meter, so we will redraw the structure using this length, 65.84 meter. Okay, then continue with the flow net as usual. If you can see here, this is the initial condition. Okay, then when we redraw the structure using the new x elements, so the length of the base will be shortened. Okay, then we will draw the flow net as usual in isotropic and ensure that all the rules follow. Okay, so we will have the flow net with the flow lines and also with the equipotential line.